Hey everybody, so this is your bell ringer for Tuesday, October 27th, 2020. I'm gonna run the bell ringer here like we're looking at my quiz on Canvas today. So we're just gonna work on it from here. But just like normal, we'll look at the questions together. I'll give you a chance to answer, and then we will check the answers together. So our first question says, we're going to use our inequality symbols, so greater than, less than, or equal to solve the inequality below. So 14/7, is that greater than, less than, or equal to 2/4? Go ahead and give that a try, and we'll answer it together here in just a second. All right, ladies and gentlemen, so 14/7 and 2/4, these look very similar. And actually, if these numbers were to be flipped upside down, these would actually be equal. But if I am to simplify both of these, 14/7, I know I can take, because 14 is larger than 7, I can take groups of 7 out of it. I can actually take 2 complete groups of 7 out of it with nothing left over. So 2/1 or just 2. So 14/7 is equal to 2. Now let's choose a different color here. I'll do good old red for 2/4. 2/4, on the other hand, 2 is less than 4, but I can actually divide both of these numbers by 2. Let's get all of these into the simplest form. So divide 2 by 2 is 1, and 4 divided by 2 is 2. This is actually equal to 1/2. So actually what we're asking here, if we simplify both these fractions, is 2 greater than, less than, or equal to 1/2? And our answer would be greater than in this case. That would be our answer for this first one. All right, let's try number 2 together. Computer's running a little slow today. All right, it says find the products. We're going to multiply these two numbers. I have 37 and 4/10 or 41/100, whichever way you want to look at it, times 2 and 1/10. Go ahead and try that out, and we will work through it here in just a second. Okay, so let's see how you did. I've got 37.40. I can add that 0 in. I can leave it out, actually. It doesn't really matter either way. I'll leave it in because I bet some of you used it. And 2.1. And again, we're going to pretend like these decimal points don't exist while we work through the problem first. We're just going to add the decimals back into our answer. So I have 1 times 0, which will give me 0. Start from the 1 spot over here. 1 times 4, of course, is 4. 1 times 7 is 7. And 1 times 3 is 3. That part was pretty easy. Now remember, we're pretending like this decimal point isn't here, so this is like a 20, which means I have to add a 0 since we're dealing with the power of 10. 2 times 0 is 0. I can just multiply normal. 2 times 4 is 8. 2 times 7 is 14. Drop a 4, carry our 1 up. And 2 times 3 is 6, plus 1 makes 7. We'll add these guys. We got a 0, a 4. Let's see, 7 plus 8 is 15. We'll have to carry a 1 up. 3 plus 1 is 4, plus 4 makes 8. And our 7 out in the front. So we have 7, 8, 5, 4, 0. That's way too many digits, but look, we have 1, 2, 3 digits to the right of a decimal point in our question, so we'll add that to our answer. 1, 2, 3. So we'll go right here by the 5. And this makes sense because 37, which is right around 35, I know 35 times 2 would give me 70. So 37.4 times 2.1, 78 and 540 thousandths. That seems like a much more reasonable answer than moving our decimal point left or right. So that would be our correct answer for this one. All right, let's rock on to the next. Only got 3 more to go. All right, we've got a story problem here. So I'm going to read it to you. We'll go through and do the cube method here in just a second. So it says that Melissa is making clothes for her dolls. She has 7/8 of a yard of fabric. Each doll shirt requires 2/7 of a yard of fabric. How many shirts can she make for her dolls? So go ahead, try that one out. Think about what numbers you're going to use. What is the question being asked, and what is the operative word to let you know what operation you're going to use. Go ahead and give it a try. We'll check it here in just a second. All right, guys and gals, are you ready? All right, so if we use the cube method, we're going to circle our numbers first. So she's making clothes for her dolls. Melissa is. She has 7/8 of a yard of the fabric, almost a full yard. Each doll shirt requires 2/7 of a yard of fabric. How many shirts can she make altogether? Well, there's our answer. How many shirts can she make for her dolls? That's the question we're looking for. And last but not least, we need to know what is our operative word. Okay. Each. Each tells me that I'm going to take my 7/8, which is our larger amount, and I'm going to break it into groups that are 2/7 of a yard long, because I'm making repeated shirts. That is division, ladies and gentlemen. So let's divide this guy out. I'm going to take 7/8, and I'm going to divide it by 2/7, or divide it into groups that are 2/7 of a yard long, which is what we really want to do. And remember, when we are doing this, we are going to keep, we are going to change, and we're going to flip. So keep our first factor the same, which is 7/8. We're going to change division to multiplication, since I said factor there, right? And then we're going to switch this guy. We're going to flip him upside down. So we're going to take the inverse of 2/7, which is 7/2. We're going to get a really big number. We're going to get 7 times 7, which would be 49, and 8 times 2, which would be 16. Now, these numbers are both pretty large, which means I can take pieces out of this. So the first thing you've got to do is figure out how many times we can take 16 out of 49. Those would be complete groups of 16, which would give us a whole thing. I happen to know right off the top of my head that 32 is one option. So 32 would be 2 times, and then another 16 would be 48, which is almost where we're at. So we can actually take 3 groups at, and 49 minus 48 would be 1 piece left over. So our friend Melissa can make 3 1/16 t-shirts. That one was a little more difficult. Those division and fraction problems can sometimes be. Just remember, keep, change, flip, and then when you're done, you can use just regular long division if you need to, but divide the numbers out. If your top number is larger, that will give you how many pieces that you have left over, and your remainder goes over your original denominator, and that will tell you the fraction that goes with your whole number. Just like we just did. All right, let's try the next one. Number 4, we're going to find the quotient. This is a little more straightforward. We just need to multiply these guys out. So go ahead and multiply using your keep, change, flip method, and we'll check it here in just a second. All right, guys and gals, this should be pretty simple after the last one. We're going to take our 6/9. There's our keep. We're going to change division to multiplication, and we're going to flip 1/3 to 3 over 1, or 3 whole things. We're going to multiply that guy out. So numerators, we just multiply straight across now. 6 times 3 is 18, and 9 times 1 for our denominators is 9. And ladies and gents, if you know your multiplication facts, you know that 18 over 9 is, or 18 divided by 9 is 2. So 2 would be your quotient for this division problem. That one was pretty straightforward, a little bit easier than our last one, right? Okay, time for our last question here for today. We're going to find a quotient again, but we've got long division this time, and this one's pretty straightforward. So go ahead and try that long division problem, and we will check your answer with mine here in just a second. Okay, guys and gals, so we have I'm going to rewrite over here just so I've got a little more room. because I have a feeling we're going to have a couple of digits we got to deal with here. All right. So again, I've got a double-digit number out in front of my maniculum here. So since my divisor is 2 digits, I need to group these things into groups of at least 2 digits in order to divide. Now, as I look at this, 25 is pretty easy for me personally, because I know those go into 50s and 100s really easily. So I am going to look at starting with groups of 2. I'm looking for multiples of 25, 50, or 100. That's what I'm going to be looking for. So I know that 25 cannot go into 16. I can't take groups of 25 out of 16 because it is too large. But I can take groups of 25 out of 167. And I happen to know the closest I can get to with 25s, if I think of quarters, would be, if this was $1.67, I can get to $1.50. That's going to be my closest, and I happen to know that takes 6 quarters. So I'm going to do that here. 6 times 5 is, of course, 30. 0 with our 3 over here. And then 6 times 2 is 12, plus 3 more makes 15. Here's my $1.50. All right, I'm going to subtract this out. 7 minus nothing is 7, and 6 minus 5 is 1. Of course, our 1s will cancel each other out. You can put a 0 there if that helps you keep place. It doesn't for me, so I'm going to leave it empty. And I'm going to drop my 0, which is our next step. I know I'm okay here because 17 is less than our 25. Now I can think of how many times 25 can go into 170. I actually have to know off the top of my head. That's again going to be 150. It's going to be the closest number I can get, because with quarters, if I add another quarter to $1.50, I get $1.75, and that's going to be a little too big to take away from 170. So my answer here is going to be 6 again. And again, I'm going to get, well, probably the same answer I did before, which would be 150. That's an okay step to take. If you feel pretty good about your multiplication the first time, you can go ahead and drop that number in for your second set. Of course, 0 minus 0 is nothing. 7 minus 5 is 2. And 1 minus 1 is nothing again. I have this left over. And because I'm allowed to use a remainder in this problem, and I'm at the end of my digits, I can take this and put it with my remainder. So I would have an answer of 66 with a remainder of 20. And there you go. That's it for today. I hope those were good. I know there's a lot of division today. But hopefully you needed some help with that, and it was a good reminder of the things we need to do. So don't forget, when you're dealing with fractions, keep change and flip. When you're dealing with long division and with larger numbers as your divisor, you're just going to think of your number in chunks that you know. It's always guess and check. And last but not least, when you're multiplying by decimals, make sure that you're just treating multiplication like normal, and then you're dealing with your decimals at the end by placing as many in your answer as were in both factors of the question. All right, guys and gals, we're going to move on now to a little bit of a mini lesson and then into some work today dealing with absolute value. So good luck, and we'll talk to you soon.